What's up guys? So today we're gonna talk about our FF28 RC project, which is kinda in the works but not really because I've been pretty busy. So if you guys didn't know, it's just me working on the project, like not really anybody else. We don't really have a team. I say we, but this is 4ENTHUSIASTS. So pretty much this is our version 8 of this project. Like not just this part, but we have different variations of the car already done, but it's not exactly what I want right now, so that's why we're going to version 8. And some versions are not completely finished while others are, and I'm trying to scale which scale I want. So right now at the moment I want it to be a 1/10 scale, but it's more like a 1/8 or 1/9 scale. I might do a 1/9 scale. Not really many people do a 1/9 scale, so might as well. So I'm trying to give you a little overall of this differential that we made. It's pretty basic if you've seen the RC differential. I have like the other variations, other versions of this project that we did. I technically made like an LSD, so it's like a clutch plate LSD on both sides, but it's too complex. And I was gonna do a version of a torsion differential, but that's licensed. There's also another one, but it's too much complex, and the manufacturing for a helical gear, it's too pricey. So just for now, and most manufacturers like Tesla and Porsche that makes electric cars, they use open differentials, and they use torque vectoring by braking, for like braking on each side of the axle. So really there's not that much benefits of a LSD in an electric car because you can do torque vectoring pretty much easily. And other manufacturers like that uses ICE engines like McLaren, they use open differential and use braking to kind of mimic an LSD. But anyways, let's get into the project. So the basic materials that we're using for right here, it's kind of like a high strength steel, kind of high carbon alloy. Not really sure what material I'm going to use so far, but primarily it's going to be a sintered metal because CNC will cost way too much, and this is going to be pretty mass produced. And the differential case right here, we're going to use aluminum, so it's going to be a 6061 aluminum. It's pretty strong and pretty lightweight. And this piece I haven't like decided yet, but for now it's going to be like a nylon plastic material. It's going to be a plastic injection, so plastic mold injection. So this could either be another aluminum piece or a sintered metal piece. I'm not sure yet. I really don't want to have this differential weigh too much because we're using mod 1 gears, so it's about, I don't know the US one. Sorry, I don't use like the 30s T or the pitch. There you go. 32 pitch, 64 pitch. I don't use that. I use the mod gears, which is mod 1. So I'll probably make another explanation about it later, but anyways. So if I go to the properties right here, we go to physical right here, we can update the weight, and it's about 180 grams. So that roughly is about 0.18 kilograms, and that's, you could get about 0.4 pounds. I don't know how many that's in ounces, but it's pretty heavy. I'm trying to save weight. That's why I'm kind of deciding if I want to keep this in aluminum or plastic, but I'll show you guys the design later. But just the exterior outside, we're using M3 by 11 millimeter button screws. So I was gonna go with 4 millimeters, but that's overkill. You don't really need that much. So if I kind of remove these right here, I remove the center case. Also remove this ring gear here. So the basics, this is a ring gear right here. This one's what we call a pinion, and then I'll show you guys the inside stuff. I'm trying to remove this one as well. This one's a pinion. So this is what's pretty much inside the differential. It's pretty much like any basic differential you see, except for majority, like in cars, this is like the casing is open because there's fluid inside the differential casing, the differential housing, and then the case in the RC we run it dry, while in cars the entire casing is fluid, which is what we're actually going to do. We're going to make the entire thing a wet housing system to lubricate everything, just not inside this. So with RC cars, you can, since it's an open differential, you can kind of manipulate to be an LSD by how thick the fluid you're going to use. But that's like pretty much another topic. It's actually pretty cool to see. And these are the gaskets for the to seal the case cover, sandwich it between the ring gear, the differential housing, and the cover plate. And these gaskets, I can remove these, and after that you can get to these three M3 screws right here, which are these buttons, and they're 11 millimeters in length. I will remove these, and then we have some pretty huge bearings. The outside diameter of the bearings is 21 millimeters, and the inside bearing diameter is 12 millimeters, and the width of the bearing is a 5 millimeters. So that's a pretty big boy right there. We're gonna make that invisible, and then after that we can get to right here. So these are the Diff Cups. I wanted to use CV joints on these as well, but it would make the housing way too much wide, and it's not gonna work with what we want to do. So a dog bone Diff Cup is more than enough. We're gonna use CV constant velocity joints on the axles, so that would be more than enough. So let's just remove these. Whoops. Alright, now it looks a little bit naked now. I have an animation that we did, a video, if you guys want to see that. It'll make this much more easier. Alright, so we have these O-rings right here. These are about 2 millimeters in width. So these O-rings seals the fluid that we're going to use inside here to prevent it from escaping outside the casing of it. So we use a gasket to seal the covers, and we also use this because there's going to be a shaft, which is the diff cup that goes through to connect to this. Oh, I forgot to show you guys the gears. This right here is the side gear. These are the spider gears. Some people may call it planetary, but I'll just call it side gear and spider gears. So the spider gears, there's 4 spider gears right here, and 2 side gears on each side of the axle. And we can remove these. Whoops. Sorry guys, there's like a lag. Okay, after that, the O-rings, there's going to be a washer to seal that O-ring right there. And here you go. And you can see that there's pins right here. These pins connect to the diff cup that connects to the side gear right here. And for us, we're using, I would say this one would be a, let me take my measurement tool. Yeah, this one is a, we were initially going to go with the 3 millimeter, but I think with some stress analysis right here, we can go for a 3.5 depending on how strong this is right here, because there's not that much material right here to be strong enough to hold the load of the side gear with the pin, but we'll just do some more testings later. Then you have this cross pin right here that connects the spider gears, and each spider gear has a washer right here, so there's at least a contact patch, because we're gonna, the housing of the differential is aluminum, so this just makes it much cleaner and has more surface to bite on. And these are the spider gears right here. I guess we can remove all of these washers. There you go. And you can see these cross pins right here. Oh, did I only show 2? Okay, we can remove these. Then we could remove the side gears. These are 20 teeth. And there you go. Your spider gears like that. So we have most people, some people they'd run 2 sets of spider, only 2, just 1 pair of spider gears, and majority of people will run 4 to handle the load of the differential. There you go. And then what you have left is the crosspin. This one's what holds the spider gears. So yep. So if we reassemble everything else, this is what it pretty much looks like. We can change the view right here with the hidden edges. It just looks much more crazier. It looks actually pretty cool. You can see all the stuff in there. Let me see right this. Yep. So this is actually a pretty beefy boy. I think the OD is it's more than 60 millimeters. So we're gonna pretty much run a pretty big wheel and tire setup. And I don't know if you guys have any recommendations, but for the pinion gear right here, it's kind of pretty hard to see. For the pinion gear, we're either gonna run like a flat shaft, or we're gonna run a spline shaft, and we're not sure which one we're gonna do. But there's also a bearing right here, so we're all using metal bearings. Pretty much everything is metal. I was initially gonna use plastic gears to keep the differential much lighter, but I think selling metal, it's a marketing term that a lot of people like. I gotta get metal axles, metal hub carriers, but those are gonna deform. You really want plastic during those parts, unless you're like tracking it or like it's just on road. But in general, plastic will work much better, and if you need to replace it, obviously it's much cheaper depending on the part. I kind of want to go spiral gears, but like he'll go like about, I don't know, 20 degrees or 45, but these straight cuts shall do. And yeah, about the weight, I need to remove more material on this right here, the ring gear. Here, let me enable all of these. So this ring gear right here, it has a lot of material left. If you can go to the properties, see, this is the most heaviest part right here. It's 54 grams, which is pretty heavy. I would say a quarter weighs 6 grams, and divided by 50, I don't know. What, you can get 6, 5, 8, 9 quarters. 9 quarters is pretty heavy, so yeah. This one is the most weight that I need to remove. Other than that, I think it's the Diff Cups. Let's see the Diff Cups. The Diff Cups are pretty heavy as well, because we're using a pretty thick, the diameter right here, right here, the diameter is 8 millimeters, and it's a solid piece. Yeah, I'm not sure if I want to drill through it, because right here, it's a 4 millimeters right here, the inside diameter. No. Oh, sorry. I think this is like a 2 millimeters. Then you subtract 2 by 8, you get 6 divided by 2, so 3 millimeters each side thickness. And I don't know if that's enough, but we'll see. I'm still learning on how to do stress analysis, so yep. And after the differential, I think I'm gonna do the motor mounts. After that, do the dog bones, and after that we can do the axles and pretty much build the body around it. I want this to build the drivetrain first, the powertrain first, because the body, I have been drawing this body design for a pretty long time, over like 4 years, and I want to get this powertrain correct first. So once I feel like this design is pretty good, I'm gonna do some 3D printing, print these out, assemble it, and see how it works, and I'll get back to you guys. So thank you guys so much for the interest of this RC project. I know you guys are pretty excited to see it, and I know it's been a long time ever since we posted on our RC account, but it's slowly going. So yeah, thank you guys for watching.